Is your SWR too damn high? Is it impacting your ability to get the contacts that you want or enjoy the hobby in a way that you deserve as a licensed amateur radio operator? Do you sit around in your ham shack wondering what you could do about it? Well, this video might just help you out. So let's take a few minutes to talk about what is SWR. So SWR is more correctly referred to as VSWR, sometimes pronounced VisWR, and it stands for Volting Standard Wave Ratio. Now I know some folks are going to come in here and say it can also be current, and you can call it isSWR, but we're not going to do that. It's a measurement of impedance match between a transmission line and the load, our antenna. It's expressed as a ratio. For example, 2 to 1 is a 100 ohm to a 50 ohm match, meaning the ratio is 2 to 1. Now, a couple of different things that impact our SWR. The first being antenna size. Antennas are designed for specific frequencies, and their physical length is tuned to match that frequency. When you attempt to operate off of that frequency, your SWR may shift and go up. Loose or bad connections. So poor connections or corroded connections between the transmission line and the antenna can increase the impedance mismatch and lead to a high SWR. Then we have bad or damaged transmission line. If the transmission line, such as a coaxial cable, is damaged or deteriorated, it may drive up your SWR. Also, the location of your antenna can impact your SWR. The location and height of the antenna can impact. An antenna that is installed too close to the ground or in an area with significant RF interference can lead to higher SWR readings. If you want to learn more about SWR in detail, I've got a number of videos on that where we go into all the ins and outs and everything you want to know about SWR. So in addition to manipulating the characteristics that we just spoke about to your antenna and your antenna system, which includes your transmission line, some people take advantage of things called antenna tuners. And this would be an antenna tuner. Now, antenna tuners are often called different things, like an ATU, like a transmatch, a matchbox, an antenna coupler, a magic box. They call them all kinds of different things, but for the purposes of this video, we're going to call them an antenna tuner or ATU, antenna tuning unit. So this is one by LDG, and it's one I like quite a bit, and it's the AT100 Pro 2 auto tuner. And as you can see, these antenna tuners come with well-marked function controls here. You can tell exactly what they do. And I'm just kind of kidding about that. So oftentimes you need to use the instruction manual as a Rosetta Stone to understand what these different functions and features do. Some of them are a little bit easier to understand, some of them are a little bit more difficult to understand. Antenna tuners come in a variety of power ratings, so you want to make sure that you get one that's appropriate for the use that you want to do. An antenna tuner may say that it's good up to 100 watts, but that's typically single sideband, so you might want to look and see what it does for digital should you happen to be an FTA operator and ruining ham radio. So sometimes they come with various displays. So here you can see your power out and your SWR via an LED bar graph. You can put the antenna tuner in bypass and not use it at all if you want. I'm not going to go into exactly how this antenna tuner works. I believe I have a video on it. If I don't, I'm sure many other capable YouTubers have one. So on the back of this particular antenna, you have a couple of different things. One is a grounding lug. So make sure you always ground your equipment. It's a best practice. You would feed your radio into here into this TX control. And then with this particular tuner, you can use two different antennas and you can toggle between those if you choose to do so. It also has a control device. So some of these with control devices will come with cabling that you can connect to your radio. Be specific when you're buying one of these to make sure that you get the correct interface. Maybe you have an ICOM, maybe you have a Yaesu or something else, and you want to see if the control cable is appropriate for your needs. You don't always need to use a control cable if you have an auto-sensing antenna tuner. Antenna tuners like this one, which is an automatic antenna tuner. And so that means that you can set this up and configure it to tune on the fly without any human intervention. And you will need power. And you need to power these types of antenna tuners with a 12-volt connection. And here's a little bit of a different old school antenna tuner, and this is what we would call a manual antenna tuner. And on here you have various capacitance and inductance controls. This one adjusts the interface to your antenna, this one to your transmitter, and then this is shared. This has a T-match network, and I believe I've got a video specifically on this one, and I take it apart and talk all about its inners, should you want to learn more about this particular tuner. Also on the back of this one, like the other antenna tuner, we have our ground lug here, but this one allows you to connect a coax to your antenna and a coax to your transmitter, But you could also use balanced wire, or you could just use a single long wire if that's the type of antenna that you're using. So there's a lot of different ones on the market, and if you do decide to buy one, you should get one that's appropriate for you. Okay, I just wanted to show a couple of more tuners at a high level. So in the upper left-hand corner, we have a lower cost Chinese tuner, and this is an ATU 100 external EXT. And you can see it does have a little bit of a power display on there. It's a small OLED interface, and it shows you your power and your SWR. It shows you your inductance and your capacitance, should that be important to you, and it has various controls. Now, some tuners tend to be what's called auto-sensing, meaning that you don't have to have a control cable hooked up to your computer, and it should do its magic should you have the tuner turned on and configured properly. Antenna tuners can range in price significantly. On the upper right-hand side, we have a much more expensive MFJ Deluxe Versatuner 2. This one's the 994E, very, very popular tuner. It's a manual tuner. And you can see this one has the cross needle display. And I do have a video showing how to operate, interpret, and read cross needle display devices, should you want to check that out. But this one has a little bit more controls, and then you can see that it also has power selection where you can toggle between 30 and 300 watts. And then it also has multiple antenna connections, and you would use the antenna selector for that. In the lower left-hand corner is the same 901B that we just took a look at in live action person 3D view. And then on the right, we have a more expensive tuner that is designed specifically for a one type of radio, the 705. Now you can use that one for other radios, but this one was built and designed for 705. So one of the things to pay attention to is sometimes there'll be tuners specific to the radio, and then you'll have tuners that you can use for multiple radios, and then some tuners you can get different control cables to use with various radios. Now, the tuners that we looked at in the previous slide are tuners that you would connect up to your radio inside of your ham shack. Some folks choose to mount an antenna tuner out at their antenna or at the base of their antenna. And so this is an RT100, I believe. It's by LDG, and this is what we would refer to as a remote antenna tuner. So antenna tuners like this have a controller box, and you mount the controller box inside of your ham shack. That way you can operate the antenna tuner, and you run a power cable out to your antenna tuner itself. As I mentioned, this is mounted out at the antenna. We'll talk a little bit about the pros and cons of why you would want one of these versus a shack-mounted antenna tuner. So the antenna tuners we looked at so far are what we would call external antenna tuners, meaning that they're external to your radio, and they have a much higher matching capability. Some radios come with a built-in antenna tuner, and typically those are matching around a 3-to-1 impedance. External ones typically do 10-to-1, but some of them do much higher. And that means it can handle an SWR up to 10-to-1 or beyond. A 3-to-1 means an SWR of 3-to-1. And that's an approximate evaluation because SWR is impacted by the impedance at the feed point where you're connecting your antenna. Our impedance is made up of pure resistance and a reactive component that is either inductive or capacitive. So you may have an antenna that's reading higher than a 3-to-1, and your 3-to-1 tuner can tune that because of the makeup of the reactance. Anyhow, here are a couple popular radios. The first one in the upper left is the Xiegu G90, and this has a fantastic antenna tuner. In fact, it's so good, people actually refer to this device as an antenna tuner with a built-in radio. The other two radios, the ICOM 7300 and the Yaesu FT991, their 991A is the more recent version of this. I just couldn't find a picture of that. Anyhow, they have a built-in 3-to-1 antenna tuner that works reasonably well. A lot of people will refer to a 3-to-1 antenna tuner as a touch-up antenna tuner because it just touches up the SWR as you change frequencies across the band of interest and the one that your antenna is designed for. In this slide, I have a picture of your typical ham, and you'll see a lot of people stoically say that they only use resonant antennas, and they don't need to use an antenna tuner. They don't want the loss that comes along with using an antenna tuner. Well, there's a little bit of a fallacy here, and I don't really necessarily know if I understand it. I suppose a resonant antenna with no antenna tuner is a good thing if you only operate on one frequency or very, very close to that frequency. Because an antenna is only really resonant on one frequency within its band. It doesn't make any sense for somebody to say, I only use resonant antennas unless they're operating on just that frequency. Once you move away from that frequency, that reactance kicks in that we talked about. So reactance is dependent upon frequency. It varies as you move up and down the band across your spectrum. So your antenna is not going to be resonant on every frequency in the one band. And then if you're trying to use a multi-band antenna, this issue becomes more complex. The only resonant antenna that I know that's resonant on all frequencies would be a dummy load, like the one depicted here. So let's talk a little bit about a typical setup that we would see out in the real world. And at the bottom, we have a little bit of a diagram that depicts a radio feeding into a tuner. Now, when you transmit on your radio, you have forward power that goes out to your antenna. Some of that power is reflected back, and it almost always happens because you almost never have a perfect one-to-one SWR. In fact, I've never seen one if you look out a couple of decimal places. So let's pretend we have 1 dB of loss in our transmission line. This means we have lossy coax, and 1 dB is relatively low. So this would mean that if we transmit 100 watts, only 79 watts make it to the antenna because of the 1 dB of attenuation. So with an SWR of 2 to 1, only about 70% of our power is absorbed by the antenna. About 9 watts is reflected back. And then this 9 watts, as it comes back as reflected power, suffers line loss in the reverse direction, with only about 8 watts being returned to your radio or your tuner if you have one. And then this 8 watts is re-reflected and it suffers the loss again. So because of this, a lot of people will say that you have lossy coax, you're not getting your full power out, and then because your tuner, the SWR, traverses back and forth, you incur repeated loss. And people will move the tuner from where it is here in this picture out to the antenna. And that is why folks would use the remote antenna tuners that we looked at earlier. Now, in the case of the antenna tuner that we looked at, you connect it to your antenna with coaxial cable. So you do have a little bit of this ping pong back and forth between the tuner out here, but your losses are significantly minimized, even if you're using the same coaxial cable, because the length is different. So what does all this mean? It means you probably want to look at getting an antenna tuner or buying a radio that has an antenna tuner built in, or using antennas that don't require an antenna tuner, which is going to limit your operating capability. So what I wanted to do is I didn't want you just to believe me. I could be another one of these YouTubers who's trying to get views and push affiliate links. What I'm going to do is I'm going to pull up an article from the American Radio Relay League that's called Begging or Appealing to Authority. And we're going to take a look at this article and see what they have to say on the matter. So here is an article, and I'll post a link below. Don't worry, it's not an affiliate link. And it's to the ARRL website, the American Radio Relay League. And this is from a QST, and I believe it was in 1996. This article is written by a gentleman by the name of Steve Ford, WB8IMY. And he's the assistant technical editor, or at least was at the time of the writing of this article. Thanks, Steve. We appreciate it. So in this article, he talks about, do you need an antenna tuner? Maybe yes, maybe no. It all depends on the type of antenna and feed line you're using. And that is a very typical ham answer. So what we try to do as amateur radio operators is educate ourselves, and then we learn things, and then we can apply those to our specific setup, configuration, and needs. So that's why answers tend to be, it depends, because you need to configure a few things when making a decision or determination. And he goes on to say that there's a lot of mythology surrounding antenna tuners, especially when the conversation turns to what they can and cannot do. So a lot of people want to argue and say, does the antenna tuner actually tune the antenna? Traditionally, as hams, we're taught that you can tune your antenna by adjusting or modifying the physical characteristics of the antenna. Those are some of the things that we talked about earlier in the video. Some people claim that the transmission line is actually part of your antenna and acts as an impedance transformation device. And when you tune the antenna tuner, you're actually tuning the antenna physically. I don't know what I believe, and I don't really know if I care. What I need to know is that the antenna tuner makes a match between the expected 50 ohm input of my radio and then my transmission line. Now, what happens on the transmission line is another subject of debate when it comes to SWR, but I think this article does a pretty good job of kind of summarizing what's going on. So what Steve says here is every antenna has an impedance expressed in ohms. This is same is true for your feed line that you connect to your antenna. He says impedance sounds like a complicated beast, and it does, so we're not going to go too deep into it. If you want to learn more about impedance, I have a video specifically titled Impedance where we get really, really into it. And he just says here in its simplest terms is a combination of inductive reactance, capacitive reactance, and garden variety of resistance. And for this video, that's really all you need to know. So he says the impedance of the antenna depends on a number of factors, including the length, operating frequency, height above ground, and proximity of metal objects, and even weather conditions. I think we covered that already. Here he says your feed line does more than simply connect your radio to your antenna. It acts as an impedance transformer. That is, the impedance of your antenna is transformed by the feed line into the value your radio sees. And that is absolutely true. You can measure your antenna at its feed point, and then you can measure your antenna at the end of the transmission line. And even if you see the same SWR readings, the mixture of reactance changes over the length of that coaxial cable. And then he says this system impedance acts as a load for the energy created by your radio. And he's got a couple of different diagrams here that we want to pay attention to. So if you take a look at this top one, figure 1, if you have your radio just connected to your antenna, and in this case have a 3-to-1 SWR, you're going to get a lot of reflected power back into your radio. This reflected power comes back as higher voltage and can cause damage to the internals of your radio. Now, some YouTubers claim that that doesn't happen. I don't know why they would think that, because it really does. Modern radios, like some of the ones that we looked at earlier, will have a fold-back protection circuit inside the radio. So as this voltage goes up, the radio puts out less and less power. So that way that voltage doesn't damage the internal of the radios. You may see this if you're operating your radio and have a high SWR condition where your power out seems to be going down. In the second diagram, figure 2, you can see where he explains the same condition that we went over. And it says by using the antenna tuner, you can adjust the impedance of your the transceiver sees to a hospitable 50 ohms. And there's a little bit of jank in this PDF file, and I don't know why. Somebody must have sneezed while they were scanning it in. The antenna mismatch of the line still exists, but the tuner protects your radio from the RF voltages while allowing it to develop its maximum output. And what you're really doing is that you're moving where in your transmission line the overall system sees that SWR. Here it's at the output of the radio. Here it is at the output of the tuner versus the output of the radio, protecting the internals. So over here on the right-hand side, it says, how does an antenna tuner work? And in its most basic form, an antenna tuner is simply a network of variable inductors, coils, and capacitors. By adjusting these coils and capacitors, you counterbalance or cancel the effects of the inductive and capacitive reactance on the transceiver end of the feed line. So on the second page, it's a little bit blurry, so I don't know whoever was scanning this in. They might have been drinking. But you can get to this article. And he talks about using an antenna tuner if you're using open wire or ladder line. And a lot of folks do this, but not everybody. In fact, most people use coaxial cable. He says that this offers low loss at HF frequencies, which is much better than coaxial cable. And he says down here that you need to use an antenna tuner with a built-in balun to form a bridge between the balanced line and the unbalanced output of your radio. A balun is a type of transformer that converts balanced feed lines to unbalanced or vice versa. Get it, bal to unbal. Then he says most antenna tuners use a 4-to-1 balun to convert the impedance of an open wire feed line to a value that the tuner can handle. And I've got tons of videos on baluns and how they work, if that's something you're interested in. And he goes through a couple of different conditions. He says when you attempt to use, say, a 40-meter dipole on 10 meters, a big mismatch will develop along with a high SWR. By using the antenna tuner, you may be able to create a 1-to-1 SWR at your transceiver. And what he says here, he says he may, because the mismatch sometimes can be too great beyond the capability of your tuner to handle. And we talked a little bit about that earlier. So if you buy an antenna tuner, make sure you understand its use case and its capabilities. Down here is another reason why you may want to use an antenna tuner. If your antenna has a narrow SWR bandwidth on some bands. So what he means is that sometimes a multi-band antenna, so this is an antenna that you can operate on maybe 40, 20, 15, and 10 meters. They don't have low SWR from one end of each band to the other. There's usually a range, and they express this in kilohertz. So typically what you would look at is something called Q factor, and maybe your antenna is 2-to-1 across the entire band. And in some cases, it goes down to maybe even 1-to-1. As you drift from your original frequency, and this is to my point about people who claim to only use resonant antennas, your SWR goes up, and you may want a tuner to be able to pull this back down to a better match. He says don't bother with an antenna tuner if your SWR is 1.51 to less. And that is because 1.51 or less is not really that serious. And then if you put an antenna tuner in place, you may have other losses. And basically, 1.5 is good. He says if you have a high SWR in UHF and VHF frequencies, you might not want to use one. And then he talks about all the different losses in the coaxial cable, and it just might not be something that's of value to you. He talks about if you're interfering with TVs or telephones or other appliances. I think this may be a holdover from older days. In any event, an antenna tuner is really not going to help you if you have an interference or causing interference problems. You probably want to look at a filter. Now, an argument could be made that an antenna tuner does act as a filter in some capacities, but it's not the best solution. And he also talks a little bit about things that you may want to look at when buying a tuner. I'll let you read this because I've kind of already covered it. And he shows some of the innards of different tuners. Anyhow, that is about it. He gives you some more stuff down here to be wary of, power ratings, but we cover all that. And then he says buy or build. We're appliance operators these days. We don't build anything. And I think that's going to wrap up the video. Hopefully this helped you make a determination if you need to buy an antenna tuner or not, and gives you a little bit of guidance as to what you may want to look for. Good luck with it, brother. Anyhow, if you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. As always, thanks for watching. It's much appreciated.